All right, let's get right into it. We talk to AI practically every day, but have you ever really stopped to wonder how it actually understands us? I don't just mean hearing the words, but really grasping the meaning behind them. Well, today we're going to go on a pretty cool journey, from a classic sci-fi problem all the way to the very heart of modern AI. And it all kicks off right here, with one of the greatest Star Trek episodes ever made, Darmok. So Captain Picard finds himself stranded with an alien captain. And here's the crazy part. The universal translator is working perfectly, but they can't communicate at all. The alien just says things like this, "Shaka when the walls fell."
So the computer's doing its job, translating every single word without a hitch, but Picard is just completely baffled. And why? Well, it turns out the alien language isn't based on grammar and syntax like ours is. It's built entirely on metaphor, on shared cultural stories. So Shaka when the walls fell isn't about construction work. It's a reference to a famous story about failure. It's their way of saying, I failed, or I messed up.
And that question right there, that's the whole ballgame. It's the exact problem that had computers stumped for decades. How do you teach a machine that Romeo, Beneath the Balcony, is about love and romance and not just, some dude standing next to a piece of architecture?
This whole Darmok problem, it wasn't just something for science fiction. For a really long time, it was the daily reality for every single search engine and database we used. They were just painfully literal.
And here you can see the two worlds side by side. On the left, you've got the old way, keyword search. It was a really simple game of find the exact word. If that specific word wasn't in the document, then as far as the computer was concerned, the document didn't exist. But on the right, you have the new world, semantic search. This is a total game changer. It's not looking for words anymore, it's hunting for the idea.
And this example just hits the nail on the head. Imagine you search millions of documents for the word weakness. A classic search engine would never, ever show you a report that used the phrase, the Achilles heel of the project. To the old system, that's just a body part and some guy from Greek mythology. The actual meaning? Whoosh, right over its head. So to solve this, engineers needed a truly revolutionary idea. They had this massive light bulb moment where they realized they had to stop storing the words themselves and start storing what those words actually mean.
Now, the seed for this idea was actually planted way back in 1957 by a linguist named J.R. Firth. His concept was so simple, but so profound. He basically said that a word's meaning is defined by all the other words you usually find around it. It's the linguistic version of that old saying, "Show me your friends and I'll show you who you are." Okay, so how on earth does a computer actually capture that kind of context? Well, it turns words into numbers. Just take a look at this table. A machine can start assigning scores to all these different features. It learns that fool and moron have almost identical scores. But then, notice the negativity level for dummy. It's quite a bit lower. The model figured out, just from context, that dummy is sometimes used in a playful or even affectionate way, so it's less harsh. It's literally capturing human nuance with pure math. It's kind of wild.
But, trying to build these tables by hand for every word in every language, that's completely impossible. So the real stroke of genius was figuring out how to get a machine to learn all of this by itself. And the approach they took was, well, it was beautifully simple. Researchers just gave a neural network a sentence with a blank in it, like the child sat on the blank, and its only job was to guess the missing word. Now, at first, its guesses were total garbage. But after doing this trillions of times, getting a tiny bit of feedback each time, it started to learn. It figured out that words like chair, sofa, and carpet all tend to belong in that blank space. And in the process, it accidentally learned the concept of furniture.
This led to this incredible cascade of breakthroughs. In 2013, you had Google's Word2Vec, which made this whole learning process incredibly fast and efficient. But then, in 2017, the transformer architecture arrived, and that just changed everything. It allowed a word's meaning to actually shift and change based on the sentence that it was in.
So what's the end result of all this training? Something pretty amazing, a virtual map of meaning. It's this huge multidimensional space where every single concept has its own specific location. And to really understand this map, we just need to get our heads around three key terms.
First up, a dimension. Just think of this as a single feature or a quality. So on our map, one dimension might measure royalness on a scale. Another one might measure, is it an animal? And maybe another one measures, how furry is it?
Second term is embedding. So if a dimension is like a single axis on our map, the embedding is the full set of coordinates across all of those thousands of dimensions.
It's the unique GPS address that pinpoints exactly where a concept lives on this map of meaning.
And finally, that brings us to the vector space. This is the whole map itself. It's the entire universe that contains the location of every single concept the AI has learned. And the really cool part is that in this space, things with similar meanings are clustered close together, and things with very different meanings are miles and miles apart.
So let's see this in action. Let's say you search for something sweet that can stretch. The system takes your whole query and turns it into a single point on this map. Then it just looks around for its closest neighbors. And as you can see, chewing gum is a near-perfect match right on top of it. A worm is kind of close because it can stretch, but it's not sweet. And a car, that's way off on the other side of the map entirely. The system found the idea you were looking for, not just the keywords.
And this ability, this power to navigate the map of meaning, this is what's driving the entire modern AI revolution. It gives AI this almost magical understanding of context, letting it pivot and steer its understanding in ways that an old keyword system could only dream of. Let me show you a really wild example of this. Okay, watch how the meaning of a sentence just completely steers and pivots with each new word. It starts with the parent. Okay, we're in a family context, simple enough. Then we add killed. Whoa, okay, that's a sharp, dark turn into a crime or tragedy. Then the child. Now we're deep in this tragic territory. A simple system would be totally locked in on this meaning. But then the final word drops, process, and the meaning does a complete 180-degree U-turn, rocketing right into the world of technology. The AI instantly gets that this isn't a crime, it's a harmless computer command.
This incredible ability is all thanks to those key breakthroughs we saw earlier. Word2Vec made it possible to even create these maps of meaning efficiently. And then transformers, the architecture that's behind models like BERT and GPT, gave words the superpower to change their meaning based on the other words around them. That's what allows for that amazing U-turn we just saw.
So we've really come full circle, haven't we? We started with that sci-fi problem, a computer that could translate words but not meaning, and we've ended up here, with real-world AI that can navigate the super subtle, shifting landscape of human language. And it leaves us with this one fascinating question to think about. If we can create a mathematical map for something as complex and messy as language, what other complex human concepts can we teach it to navigate?